my name is Óbuda, and this is my official unofficial solution for the network state exam. And now is the 15th topic, which is about Dhcp. This is a cool topic. The automatic configuration of IP addresses on end devices, advantages, limitations. So, of course, now we can come up with the two approaches that we can add IP addresses as this topic says manually, not automatically by manually. But imagine that if there are, for example, in a company one printer for which we have to assign a static IP address, then of course this is good because that's easy. But imagine that there are more than 100 devices, then the administration of them is really hard and there can be misconfigurations as well. So this is the disadvantage of the static or statically manually adding IP addresses. So of course the better approach is the automatic allocation, IP address allocation, and for this we have the Dhcp. Within the Dhcp we have three approaches. We have the manual allocation, where the administrator defines an IP address and the server communicates that IP address to the printer, for example, so it will have only that one. The second one is the automatic allocation, where the administrator defines a set of available addresses, so a pool from which IP addresses can be assigned to devices like again printers, and that will be statically assigned to them. That means that will be permanently assigned. There will be no leasing time in this case, so they will be there, as I said, permanently. And we have the well-known the dynamic allocation, where everything handled by the Dhcp server, and in this case I forgot what I wanted to say. In this case, there is a pool of addresses from which the server will assign an IP address to a client, and the client will lease it for a limited period of time. That can be, for example, some hours, a day, a week, or a month. Just an example. See how it looks like. When we boot up our computer, the computer cannot communicate on the network because it has no IP address. The computer will send an Ethernet frame, a single frame. So we are talking about layer 2 data link layer. So there will be a frame sent, a broadcast that is called as Dhcp discover, because with this frame it discovers all the Dhcp servers on the network. To this, the Dhcp server will send back a Dhcp offer. And how does it look like when the server receives the Dhcp discover? Then the server will assign or reserve an IP address to that client, and will also save its MAC address, so it saves it, and will send this offer in which there will be the IP address. The client will receive the offer, will send out a request, a broadcast request, to notify the other servers that, hey, I received an IP address from this server, so I don't need you. And the server will simply acknowledge it by doing an ICMP ping. That simply means that it will ping the IP address whether it has been already assigned or not, and if it will not receive any answer for that, then it means that the IP address has not been assigned, so it can be assigned to our client. So this is how the Dhcp functionates and works. Dhcp services configuration of Dhcp on routers and end devices. Of course, on end devices it simply set them to dynamic to dynamic allocation on routers, we can set up routers to act as a DHCP server, so we don't need a dedicated DHCP server. The operation steps of DHCP, the purpose of each step, I now said it. Verifying DHCP operation, troubleshooting DHCP configuration. The troubleshoot is quite easy. We have to check on the end device whether we received an IP address. If not, then we have to check the connectivity in the network, whether the message is going out, for example, the network or not, or it is received by the router or not. And I believe that's all. The basic connectivity, the sending approaches, and the IP address. The verifying DHCP operation is quite easy because on the DHCP server, as I said, there will be an entry where the MAC address and the IP address is saved. Therefore, we can check there, and also there is a statistics approach in the DHCP server where we can check how many offer requests and other message types has been sent recently. The aim operation and configuration of DHCP relay, it is quite easy. In the previous example, I'm going to visualize it. In the previous example that I've said, here is the server, for example. Let this be a switch, this be a switch. Let this be a computer host and this be another host. So the routers are connected to the switches and the switches are connected to the hosts. Let's denote this will be router, this will be switch 1, switch 2, this will be host 1, host 2. So this was the previous example. In this case, the host simply talked directly to the router, which, for example, in this case also a DHCP server, and the DHCP server immediately replied back. But imagine that we have another router here, and this will be the DHCP router. Oops. And they are connected together. So how does it look like? I'm going to denote it with purple. This will be the internal, the trusted network, and this will be the untrusted outside network. And the problem is that if from this host a request will come here, then this router will not let these DHCP messages go to the untrusted network by default. So that's why we have the DHCP relay, because this will be the DHCP relay, because here we have to define a helper address on this, a helper address to let the DHCP messages go through from the or pass through from the DHCP server and to the DHCP server. So we are putting this helper address if we are having more routers and the host is not directly attached to the DHCP server. So in this case we need the helper address, and I forgot to say in the previous one that when the client receives or requires the IP address, of course that will be leased by a period of time, and it's important that if the leasing expires, then the client simply send out a request directly, a unicast message directly to that router, and the router will usually assign back the same IP address. So the leasing is done through a request message as well. So we fulfill the relay. The consequences of DHCP service outage solution is quite easy. For example, if there is a blackout and the DHCP server will not work, then as I said, if the IP address will be remained until the leasing time expires. Therefore, if the therefore after that, if it is expired, then the router will send a unicast message to the DHCP server that, hey, my leasing expired, can you provide me again an IP address? And simply because the DHCP server is not functioning, the client will wait a certain amount of time, and if it will not get back any reply, then it will send out a broadcast to the all other servers as well to get an IP address. So that's the solution. The operation and usage of ARP. So from here I know the address resolution protocol. I already said it sometimes that we are talking about switches, layer 2. We have a particular IP address, but here at layer 2 we are not speaking about IP address. So we are sending the IP address out and we would like to get back the MAC address, physical MAC address to that given IP address. The ARP and the boot protocol is, if I remember well, the same. I didn't learn the ARP, but the boot protocol, as its name is indicating, similar than the DHCP. It would like to get an IP address during it boot while it's booting up the computer. If I remember well, the only difference that this is only works when we are booting the computer. So if we would like to renew the lease, we have to reboot the computer. And if I remember well, in this case, the leasing time is usually at least 1 month long. So that's all about DHCP services, or the service of DHCP. And again, if I said something wrong, then I don't really care. And don't forget to subscribe to my channel.